Today we're talking about simple harmonic motion. Just to review, frequency, period. What is the word? What does the word period mean? Amount of time, right? Right. Amount of time to do what?
Oscillate once.
One complete oscillation or revolution or cycle. I like the word cycle. Why do I like cycle? Because
It's not just one way.
yeah, it's cycle could mean either going around in a circle, or it could mean from here all the way back to the same point in the cycle again, right? So it could cycle applies to both simple harmonic motion and to circular motion, which is good. What's the relationship between period and frequency? Inverse. Period's 1 over frequency. Good. Is there a difference between frequency and angular frequency? Yes, there is, because they're separate. What's the relationship between frequency and angular frequency? Hint, angular frequency is also known as angular velocity.
Oh. Huh.
Yes. So, what's the relationship?
2 pi equals angular frequency.
Angular frequency is radians per second, whereas frequency is revolutions or cycles per second. So there's a factor of 2 pi involved. Okay. Yes. So angular frequency is 2 pi over period, or 2 pi times regular frequency. That one is worth memorizing and just kind of committing to memory, because you're going to be converting back and forth between F and omega all the time in these types of problems. And that's a leading source of, oops, I forgot to do that. Just kind of like remembering that V equals R omega. Also, you should rememberize omega is 2 pi times F. All right. Now, this also is a review from AP Physics B. Let's say you had a cart set up on a track, and you had a spring hooked up on both sides of the cart, thusly. See I do that? I can do 2 dots at once. It's awesome. And you pull it to the side and let the cart go. What's the cart going to do?
Move to the left.
It's going to go, wow, 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 like that with the sound effect. And
Let's do it, and if it doesn't sound
we will do this tomorrow. I didn't have time to get it set up this morning, but I guarantee you tomorrow this is going to be the subject of conversation. Maybe even with your parents at night, because it's going to be so exciting.
My parents are.
Like, they're going to ask you what you learned in school today, and you're going to say, and I can't tell you, I can't give it away. You're going to have to wait till tomorrow to find out.
If you do a face and put your 2 fingers like that on that, would it look creepy?
Like that.
Ooh. Or tripops.
I actually have 4 fingers down, but it apparently only senses 3. Woo!
Or maybe
All
your
right.
4th finger.
That's going in the video. All right. Okay, so let's say you had a cart spring mass system. The spring mass system was oscillating back and forth. Whom, 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 whom. What's the amplitude of the oscillation? A, right. So it goes from 0 to A to 0 to negative A to 0 to A and so on. Good? Imagine you had a horizontal spring mass cart sitting on a cart. You pulled it all the way to the right to position of A in the X direction. What would happen when you let go of the cart? It's going to go back and forth and back and forth and back and forth and back and forth. Right? And if you plotted that position versus time, you would get positive A, 0, negative A, 0, positive A, 0, negative A, etc. Sound good? All right, cool. And the equation, according to AP Physics B, the equation would be the position as a function of time would be A times cosine of 2 pi over the period times t. Right? Does that ring a bell? 2 pi over period times t? What's the difference between the big T and the little t?
One period, the other.
Big
Time.
Because time may not represent full.
Which one's a constant and which one's a variable?
Big T.
Big T.
Big T is a constant, little t is a variable. Got it? Oh, in general, in math classes and in physics class, you're going to see that a lot. Capital letters stand for constants. Lowercase letters that look almost the same, but lowercase tend to be variables. Not always, but it's particularly not always in physics, but in this case it is. All right, in AP Physics C, now that we know what omega is, we know that omega is 2 pi over period. We got a cosine omega t, which is how you learned it in trig class. You guys remember that? All right, so you did something a cosine, what do you call it, bt or something like that in trig?
Yeah.
Yeah, well, it's technically known as omega, but I think they were afraid to give you Greek letters so early on in your childhood.
They probably just didn't like it when you say omega and it was a W there. It was scared.
Yes, it would have scared some people. They're like, oh my God, that looks like Greek to me.
Yeah.
All right, so if position versus time is cosine, what's velocity? Sine. Why?
Well, it's
Derivative.
no.
Cosine. Oh yeah, sorry, omega sine. Yes, you are correct. I stand corrected. So it's negative sine. All right, so good. So the derivative of a cosine omega t, well, you got to use kind of sort of a little bit of the chain rule involved there. Do you? Sort of. Yes, you do. Chain rule. And so the omega comes out front. You get negative a omega sine omega t. Wait, when does the maximum velocity occur? Well, at this case, the maximum velocity, 3t over 4 and t over 4, right? So, but at maximum velocity, it's when omega is 1?
When did sine equal 1?
Hmm?
Sine omega t equal 1?
Yeah, when sine omega t equals 1. So the maximum velocity is just the stuff out front of the sign, a omega, which is kind of cool. We knew the maximum position was a, so the maximum velocity is a times omega. Now, if you're like me and you don't like to think in terms of omega, you like to think in terms of period, the maximum velocity would be a omega, which would be 2 pi f times a, which would be 2 pi a over period. Kind of cool. And if you think about that, the units check out too, because a is distance and t is time. Good? All right, what about acceleration? What's the equation? Uh-oh. It'd be a negative cosine, and what goes out front?
Negative AW squared.
A omega squared?
It's positive because you go.
Yeah.
Ah, yeah, nice.
No, that's negative.
No, wait.
cosine.
Wait, that should be,
Negative, yeah.
I dropped a negative sign. Let's put the negative back in. So negative a omega squared. Good? All right, so the maximum acceleration, you just repeat the process. A omega squared would be 4 pi squared a f squared, or 4 pi squared a over t squared. Oh my gosh.
That.
Does that sound familiar?
That's circular.
Acceleration!
Centripetal acceleration.
Centripetal acceleration! Yes! We have just proved the centripetal acceleration equation. Remember how it was v squared over r? But then we said, I don't know where that comes from, it's just magic. Well, now we can look at it and go, oh, that v squared over r, or that 4 pi squared r over t squared, or that 4 pi squared r f squared, guess where it comes from?
Simple harmonic motion.
Simple harmonic motion calculus. Got it? So instead of writing a, we write r, and then that's the centripetal acceleration that we know and love, and we've known and loved for the last 2 years, which is great. Yes. So once again, what do you have to memorize out of all this? a omega squared, 4 pi squared a f squared, or 4 pi squared a over t squared. But you're in luck because you already memorized it. Ha! All right, next. Whew. Remember how painful it was to figure out position versus time velocity versus time acceleration versus time last year? You had all those crazy constant acceleration equations, and actually you didn't even do this derivation. I think they stopped doing it in AP Physics B. In AP Physics B, we used to do simple harmonic motion derivations like, never mind, you don't even know what I'm talking about. Okay, let's just cross out this sentence. Look how easy it is now to figure out position versus time, velocity versus time. You just take the derivative or the integral. Sine, cosine, negative cosine. So, for example, if you started the car out at the positive A position, then let go, what would its position function be, sine or cosine? You started out at positive A. Position versus time would be cosine. How come?
Because you're not starting at 0.
Which does sine or cosine start at 1?
Cosine.
Cosine starts at 1, so position would be cosine. Let's say you started it in the middle and you launched it to the right. Would position be sine or cosine?
Positive sign.
It'd be positive sine. Do you see why?
Wait, so position isn't always a cosine?
No, it depends on where you start the thing. Right? What if you started the thing on the left side in the negative direction and then let go?
Negative.
What trig function would it be?
Negative.
Negative cosine, right? Yeah. What if you started in the middle and launched it to the left?
Negative sign.
That would be a negative sine trig function.
It's
So you-
we're assuming the middle is 0.
Assume the middle is 0, assuming all the way to the right is positive A and all the way to the left is negative A. So the trig function that you're going to pick depends on the situation given in the problem. Does that make sense? Start to the right, it's positive cosine. Start to the left, negative cosine. Start in the middle, launch to the right, it's positive sine. Start in the middle, launch to the left is negative sine. Good?
What's negative cosine?
Starting on the left.
Starting on the left. Soham, you got this? Blake, you got this? All right, cool. All right, so car starting in positive A position and then let go. That means position is A cosine. Velocity starts here. What's the velocity going to start at? If you start all the way to the right, what's your velocity starting at?
0.
0. And then what's it start doing once you let go?
Accelerating.
Accelerating which? Negative. So what trig function starts at 0 and then goes negative?
Negative.
Starts at 0, goes negative.
Negative sign.
Negative sine. So the velocity function, if you start the car all the way over to the right, is actually negative sine. Hey, guess what? That's what the calculus says too. Right? And then the acceleration function, if you start it all the way to the right, which way is it being pushed? In the negative direction. And when it's all the way over, is that a maximum push or a 0 push? It's a maximum negative push. So the acceleration would be negative cosine. Does that make sense? So you don't even need calculus to figure these three things out. You can just use logic or calculus. But they should both match. All right, next up. Let's say you start a car in the middle, but push to the right with some initial velocity. I'm not going to give you the answer. Don't look. Don't peek. All right, car starting in the middle. Its initial position is 0, but it's pushed to the right with some initial velocity equal to the Vmax. And we know Vmax would be A omega, right? So what trig function would you use for velocity?
Sine. Cosine.
Positive or negative cosine?
Positive.
Why positive cosine?
Starting with.
Because it's going to the right.
It's starting with a maximum velocity. That's positive, right? So the velocity has to be what? What goes in front of the cosine?
A omega.
A omega, or V max, A omega cosine omega t. So if the velocity starts at the maximum, that means your position is starting at 0, right? So what trig function are you using for position?
Sine.
Negative sign.
Sign, positive sign or negative sign?
Positive sine.
Positive sign. So what would the equation for position be?
A sine.
A sine omega t. Good, yes.
You know how we're like using omega as an angular stuff?
Mm-hmm.
Where does the angle come in?
It comes from the unit circle, which I'm about to explain. Yeah. It comes, remember unit circle problems in trig?
Yeah.
Where you did theta, or you did the angle and relate that to the position?
Yeah.
Omega is that, just velocity instead of position. Yeah. All right, so here we go. Here's position, velocity, and acceleration for a cart starting in the middle but pushed to the right. Sound good? Okay, give me thumbs up, thumbs down on how comfortable you are with like picking an equation for initial positions based on this. Everybody, thumbs up, thumbs down. All right. Okay, good, good, good. All right, so we got this. So you can do this on your homework. Next one. Just asked about where does the, what do you ask? Omega, how does omega relate to?
Yeah, like where does the angle come into play?
Yeah, how does omega relate to anything? Right? Okay, here we go. So here's where it comes from. It comes from a unit circle. I'm not doing a unit circle, I'm doing a circle of radius A. All right? So, we know that if we just look at the cart from a side view and the cart just goes, it's just going to go back and forth and back and forth and back and forth, right? Well, the reason it's doing that, well, one of the ways to think about this, and I like to set this up as a demo, but again, I didn't have time this morning, is if you were to just look at the x component of an object traveling around in a circle, the object would be traveling around in a circle like this, right? Could I have somebody come up to the board and help me out with this? Justin, could you just have your finger trace along the x component? Too slow. What's Justin's finger doing?
Oscillating.
It's just oscillating back and forth. And I'm trying to make the red dot go around the circle at a constant velocity. So there's a relationship between the angular velocity of the red dot and the position of Justin's finger, isn't there? All right. And that relationship is given by cosine of the angle. Does that make sense? Did you see what just happened, Shiv? You're looking a little suspicious. Shivam, sorry. Yeah, you're looking suspicious. Do you understand? Okay, good. All right, so x component of that going around the circle is a cosine theta. All right, so when the position of the red dot, the angular position, is not 0, it's at some angle, right?
Yeah.
That angle we call phi. Greek letter phi. Do you guys know how to draw phi?
Circle with like a.
Circle with a slash. Lowercase phi is circle with a slash. Right. Do you guys know how to do uppercase phi?
It's like an empty set.
It's a circle with a line through it, and usually you put a top and bottom on it too. Yeah. But lowercase phi is just circle with a slash. Okay. Wouldn't you agree that the angular position would be phi would be equal to the angular velocity times time, assuming you start from 0, right? Okay, what if you don't start from 0? What if you start from a time or a position that's not 0? Say the particle starts here rather than here. Well, your starting position would be called phi naught, right? Phi at time 0?
Yeah.
That's called a phase constant. It's also called an initial phase angle. Why do we call it phase? I don't know. Think phases of the moon. Do you guys know about phases of the moon? It's like the new moon, then waxing crescent, and then waxing quarter moon, then waxing gibbous, and then full moon. Do you have any idea what I'm talking about? Right, and then on the other end, it's like waning gibbous, then waning quarter moon, then waning crescent, and then new moon again. That. Phases. Phases have to do with something that goes in a cyclical pattern. All right, so we call it phase angle because it's the angle going in a cycle. All right, so the initial phase angle is also known as the phase constant. So the current phase angle is equal to the initial phase angle plus omega t, wouldn't you agree? All right, so the complete equation for simple harmonic motion would be, for example, a cosine omega t plus whatever your initial phase angle was. Good? And then for velocity, negative omega a sine omega t plus phi naught, and then omega squared a cosine omega t plus phi naught. All right, so bottom line, if you ever see phi naught, phase constant, don't freak out. It doesn't really affect much.
Fear not.
Yes, fear not. That's what it stands for, fear not. That was awful. All right. And you know from your trig identities that there's a relationship between sine and cosine, right? Ah, darn it! I missed that all these years. Right? There's like a 90-degree difference between sine and cosine, related to depending on what phi naught is. Good? Okay. We're not going to have to do all the crazy double angle formulas and trig identities and that you had to do in trig class, so don't worry about that. The most complicated trig identity you're going to have to do is sine squared plus cosine squared equals 1. All right? I know, that one's brutal. So that's all I have.